today we are talking about the descriptive statistics, which are, we will talk about describing, exploring, and comparing the data. Let's go for the introduction. You remember when we were talking about the types of statistics, we mentioned we have descriptive, and we mentioned we have interferential, and we mentioned that descriptive is just to describe the data we have collected. Even when we have inferential statistics, we need to start with some descriptive analysis to describe the quality of data or the type of data which we have collected, which is very important for the data user or the reader. So let's go for one thing, or first part about descriptive statistics is the frequency distribution. Some of you who already studied the business statistics in your DBA, you know what does frequency distribution mean. And we explain it a little bit more. I will stop sharing the slides and I will share with you some notes which I prepared for today's class, because this statistics is very important we go with examples and notes. So, what is frequency distribution? We have for two things, for qualitative data and quantitative data. I think you remember that we talk about that we have two types of data. We have qualitative data and we have quantitative data. So frequency distribution is also applied for the two types of the data, the quantitative or the qualitative. So for qualitative data, the frequency distribution exhibits how the frequencies are distributed over various categories. So the frequency distribution for qualitative data exhibits how the frequencies are distributed over various categories. So it lists all the categories and the number of the elements that belongs to each category. I think the sentence somehow maybe have some doubt. Let's take the example, which is really clarify for us what does frequency distribution for qualitative data means. This is our example. Example saying, here we have a sample of 25 young executives was taken at random. Each executive was asked to choose only one of the 5 listed models of national cars: Myvi, Saga, Viva, Persona, Alza. And the responses are as follows. We find 25 guys that are executive and they are young executive, and we ask each one of them to choose one of those 5 brands or 5 types of cars. So the answer is given like this. First one said Saga, second one said Viva, third one said Saga, right? Fourth one said Viva, so Myvi, and so on. So here we collected 25 answers. Again, we have sample of 25 young executives. Those people or those respondents, we ask them to choose only one of the 5 listed models of national cars. So each one of them choose only one of those models. So how the answers come like this. Here we have 25 answers. You are requested to develop a frequency distribution table for the data. You are requested to develop a frequency distribution for the data. So how these things can happen? You need to just keep in your mind that the model is the variable. What did we ask them? We asked them what model you prefer. So what is our variable here, which we need to categorize, is the model of the car. So how we do this categorizing? We put the model of the car as a variable. Myvi, Saga, Viva, Persona, Alza, right? Then we need to calculate each one of those models, how many times being selected from those 25 executives. We call it a frequency distribution. It means how many times each one of those models have been selected from our respondents. Again, our example is we have 25 young executives. We ask each one of them to choose one of the cars models. So we received 25 answers. So now we need to calculate the frequency distribution. How? By categorizing our variable. Our variable category is the cars because we have only 5 models. So this is 5 categories. Then we need to count each one of those categories, how many times being chosen. So can you help me? Let's go for this first model, the MyV. How many times? 1, 2, 3, 4, 5, and 6. Yes, very good. So MyV being selected 6 times. Good. Let's go to Saga. Saga, how many times? 1, 2, and 3. Let's color Saga in yellow color. Yes, 3 times. Very perfect. The third model, Viva. Viva, how many times? The Viva is Viva. We have 1, we have 2, 3, 4, 5, 6. Yes, so it's 6 times. Viva is, sorry, 6. Perfect. Then we have Persona. Persona. Persona, how many times? Persona. 1 and 2. Yes, only 2 times. We put Persona 2. Alza? Alza, how many times? We have 1, 2, 3, 4, 5, 6, 7, and 8. Yes, Alza 8 times. How much the total should be? 25. Perfect. The total should be 25 because it's just the total number of respondents. So this is these numbers which you are seeing here. We call it the frequency distribution. It means each one of these categories, how many times being selected by our respondents. So when you have qualitative data, you need first to set the categories. Let's say we bring a group of girls, let's say 20 girls, and we ask each one of them, what type of chocolate do you prefer? And we give them 4 types of chocolate. We give them Bounty, we give them Kit Kat, we give them Kinder, and we give them what other type of lovely chocolate? Tum Tum. I love this chocolate a lot. So we give them these 4 types of chocolate, and we ask those 20 girls to choose which one of these chocolate they like. Each one of them can have one option. So the frequency distribution we can find, like 4 of them, they love Kit Kat, 5 of them, they love Kinder, 9 of them, they love Bounty, and the rest, they love Tum Tum. So like this, we call it frequency distribution for qualitative data. And this one is a qualitative because I like or dislike is a qualitative data, cannot be measured by number. I cannot say I love Kit Kat 4 and I love Tum Tum 6. No, it doesn't work like this. This one is a qualitative data. And this how we calculate the frequency distribution for qualitative data. Now we want to talk about frequency distribution for quantitative data, which is numbers. The frequency distribution for quantitative data is also will be asked to group our data and put it as a class. So the frequency distribution for quantitative data lists all the classes and the number of values that belong to each class. Data presented in this form is called grouped data. So the data, all of it is called grouped data. Let me show you. Like this one, in our example here, this one called grouped data. Then, an interval that includes all the values that fall within 2 numbers, lower and upper limit, we call it class. So this data, which is all our data, we call it group data. And the interval that include some data from upper and lower limit, we call it class. I know this one is not clear. Let's go to example. For that reason, I always say business statistics, we should go to examples. We should go to numbers. It's no way to give the class without numbers, no way to give the class without examples. Okay, so let's go for example about frequency distribution for quantitative data. Our example as follow. You just started your new job as a health educator at a vet clinic specifically designed to help children lose weight. The first cohort of children have just completed the first year of comprehensive program made of balanced diets, physical exercises, and mental support. Your supervisor wants you to compare BMIs of these children before and after the program. All children before the program have BMI over 30. The after program BMI are as follow. So, what is the meaning of that? Now you join your job, and this group of people, they were under some diet. Before that diet, all of them, their BMI, it was more than 30. Now we count their BMI and we get these results. So we have here 16 students, okay? So what you are required to do, and as we mentioned, this data, we call it grouped data, is all our data. You need to create a frequency distribution table for after program BMIs using the following class intervals. We mentioned this is the interval. When we have a group, we have upper limit and lower limit, which means like we need to put under this category all of them, all the people with their BMI between 18.5 to 25, which is considered optimal. And we need to put in the second group all people with their BMI between 25.1 to 30, which is considered overweight. In the third option, we need to put all the group of students which they are 30.1 and above, which is considered obese. Okay? So here also, we call it frequency distribution. We need to group the data, very normal, but with category. If you remember, when we are talking about qualitative data, the category based on the data itself. We don't have ranges higher and lower. For quantitative data, normally when we want to put the frequencies, like especially when the things have some limits, so we need to put upper and lower. So as example, like when you are testing your BMI, you know the BMI, which is to see whether you are fat or not, whether you are obsessed, you are like too much, you need to have like very heavy diet, or you are still normal, or you are okay. So as we mentioned in our example here, we get the BMI of those 16 students. You are requested to categorize to see how many of them are still under the optimal level, how many of them they are overweight, and how many of them they are obese. Okay? And those normally let's highlight it with red color because need to really do something for them. So our frequency distribution, we need to see, we need to count, right? How many? So tell me how many there are under first class, which is the optimal. Okay, let me help you to do it. I know because we already have 16, so it's very easy to count, but normally there is one step when we are doing these things manual. I will teach you next step how to do it in Excel. But when we are doing this one in manual, we have one easy step we can do, which is we have the tally, which means we put tick for each one is under this. Let me show you how. So first one is 13.1. 13.1, it will go to the 30 and above, which is obese. We put one tick. Second one, 24.9. 24.9 is under the first category. Third one, 22.8. 22.8 goes to also first category. Third, number 4, 23.5 also goes here. 27.3 goes here. This we call it that tally, which is optional to do, and so on. So this is one of the way to do. Second way, you just go and check one by one. So let's try the second way, which I think you follow. Between 18.5 to 25, let's highlight it in green. This one is first. This one also same. This one also same. This one also same. This one also same. It means we have 1, 2, 3, 4, and 5. They are under this category. Okay, let's see the second one, 25.1 to 30. The overweight. The overweight, how many? 9. Overweight, they are between 25.1 to 30. So let's check this one. No, this one, yes. So let's highlight where this one, yes. Anything, this one, yes. Also this, and those. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes, perfect. Good. So the last one, we have the obese. We have 1 and 2. We have 2. Right? Yes, perfect. So like this, we did the frequency distribution for this set of data. Like this, we set the frequency distribution for this set of data. Now, like this, we learn the frequency distribution for qualitative data and the quantitative data. Because if you notice here, we are working with very small set of data, like 16, 20. So it's easy, we check one by one. But if we are talking with a set of data, let's say 100, 1000. So it's no way we do it manually. We need to use some software. The easiest, the most famous, the available is Excel, because you know from your Scholar ID you can access to full version of Excel. So from Excel we can do same. We can test the frequency with very simple equation we can apply in the Excel. Let's move one extra step, which is relative frequency. The relative frequency is to show the percentage of the total number of observation in each class, which means when we are saying we have 5 people, they are under the optimal. So we want to calculate those 5, how much they are percentage from the total. So let's say if we have groups of the SOMB students in the MIU, and we said that we have 25 female and we have 75 male. So we want to know this 25, how much as percentage from the total of SOMB students. This one we call it relative frequencies. So in our example here, you can see we have 5 students that are under optimal option. And we have 9 students that are under overweight option. And we have 2 students that are under obese option. So we need to calculate how much the percentage of each, because when we are making our report, we want to say, like example, 20% of them they are under OPES option, two of them they are overweight, and 5 of them they are 5%. Sorry, we can say like 20% are overweight, 20% are OPES, 20% or like the rest of the percentage are optimal. So how we can calculate it? To calculate the relative frequency, you need to divide the number here on the total. What is the total here of those frequencies? Is 16, which is the total of the observations. So here you need to put 5 divided on 16. Sorry, 5 divided on 16. Okay? Yeah, the total is 16. So to find the relative frequency, you need to divide the frequency of this option on 16. Then take it as a percentage. So when we put 5 divided on 16 is equals to 0.3125, which is equal to 31.25%, right? So the relative frequency, you need to divide the frequency of this category on the total. So 5 divided on 16 is 0.3125. So as a percentage is 31.25. Calculate for me the second option for overweight. Calculate the relative frequency for overweight. How much? Okay. 9 divided on 16. Yes, multiply by 100. 56.25. Perfect. Thank you. Is 56.25%. Very good. Third option for the OPES, how much? So, as we mentioned earlier, this is the, what we call it, frequencies, for data frequencies for the, what we call it, for the, what, okay, sorry, I forget the word, for the qualitative data. We need to categorize, then we put, and for quantitative data, how we do the frequencies and how we calculate the relative frequency. Relative frequency, as we mentioned, we divide the frequency of that category on the total. Then we take it as a percentage. Okay? We were talking about the frequency distribution and we give some examples. Again, a little bit, we'll talk about some theoretical part, which is definitions. So frequency distribution, as we learned yesterday, is a tabulation of values that contains one or more variables in a sample. It summarizes the distribution of values in the sample, where each entry represents the frequency or count of the occurrences of values within a particular interval. And that we learned yesterday was example. It's much simpler to manage and operate the frequency tabulated data than the raw data. With the frequency tables, there are simple formulas to calculate the important statistics. So they are exhibit how frequencies are distributed over various categories. A frequency distribution for qualitative data lists all categories and the number of elements. If you remember yesterday, we give example about this, which is the cars, which is the preferred cars among young executive. And we talk about the quantitative data, if you remember, was the BMI of the kids in the school. So a frequency distribution for quantitative data, it lists all the classes and the number of values that belong to each class. Data presented in this form is called group data. And if you remember, we talk about the class Also, an interval that includes all the values that fall within two numbers, lower and upper limit, we call it a class. This all we talked about it yesterday. And if you remember in our example yesterday, we get three classes. We divided our population into three classes. Also, there is one more point in the quantitative data, or the frequencies of the quantitative data. We call it the midpoint, or class mark, is determined by going halfway between the lower and upper limit. It can be computed by adding lower and upper limit and divide by 2. If you remember our example yesterday about the BMI of students, if you remember, we put our upper and lower limit for the optimal level was 18.5 to 25. So the midpoint is 18.5 plus 25 divided in 2. So again, to calculate the midpoint, we add the lower limit to the upper limit, then we divide in 2, so it will be 21.75. This is what we call it the midpoint. Also, in yesterday, the class interval for a frequency distribution, or we call it classes of the same size, can be determined by subtracting the lower limit of a class from the lower limit of the next higher level, or distance between any two successive midpoints. So this one also we call it the class interval, which is the differences or the two different classes. And actually dividing the quantitative data, sometimes the classes can be same, sometimes classes can be different. If you remember in our example yesterday, our classes were different. The interval or the spaces between the lower and upper limit of each class were not similar. So here it depends. Some data we divide for similar. Some data has some, let's say, medical background or have some research background. So the intervals or the differences between the upper and lower limit of each class not always similar. So different type of data, we can deal with it in different way. So we have some advices for the class intervals. In case you don't have academic background about how you divide the intervals, or let's say there is no research deciding the intervals, so try your best to make your intervals equal. Second, find the suggested class interval, which is high value minus lower value divided on number of classes. Let's say you have 10 or let's say 20 or 30 items, 30 numbers. Let's say you are calculating the weight of people. So you have 30 people, you already measure their weight. So you take the higher weight minus the lower weight, then you divide the number on 2. On number of classes you are planning. Let's say you're having like 30 and you are planning to divide onto 5 classes. So you take the high weight, you deduct from it the lower weight, then you divide on the number of the classes you are looking for, then you can find suggested class intervals. Here, if your data didn't come with any specifications or any details, most of the cases you will receive the data with some details like what are the class intervals, how many intervals are required, and so on. And try to choose appropriate number of classes, which is between 5 to 15. So here how you do the frequency distribution. Here how we do the frequency distribution of the data. And this little bit we talked about it in the example yesterday. I will try to do some recap in the example. Also, we have some we call it relative frequency distribution. We talked about it yesterday. If you remember, we divided the frequency distribution of the category on the total number. Like if you remember yesterday, the BMI, the first BMI category, which was optimal, was 5. We divided the 5 onto the 16, which were the total number. We find the relative frequency of this category. So the relative frequency, it may be desirable to convert class frequencies to relative class frequencies to show the percentage of the total number of observations in each class. Each of the class frequencies is divided by the total number of frequencies, and that's what also we learned yesterday. We have a cumulative frequency distribution. How we calculate the cumulative frequency distribution for each class is determined by summing the frequencies for the class and all prior classes. This one I'm gonna to explain now in more in-depth example. So let's go back a little bit to our example. Yes, if you remember this example, I think yes, you do. If you remember yesterday, we talked about the frequency distribution for qualitative data. It was a number of cars, it was a type of car recommended by young executives in companies, and they were divided into 5 categories based on the car type. Then we find that the frequency distribution of each brand. Then we talk about the frequency distribution of the quantitative data, and we talk about the BMI of the students in the class, and we divided into 3 categories or 3 classes, if you remember. The first was between 18.5 to 25 as optimal, 25.1 to 30 as overweight, 30.1 and above as obese. And we mentioned that here, if you see that those classes are not similar to each other's, as I mentioned, the size of the class or those classes can either, if you don't have any specific background for it, let's say this obese, it has a specific background for it. It has a it's like what we call it, academic research behind it, that they say that if the BMI is lower or higher, we can consider the person based on a lot of researchers. So you use these classes. In case your data doesn't have, let's say, the ages. So let's say if you want to divide the ages also is the quantitative data. So if you want to divide based on classes, here either you rely on based on the previous studies, how they divided, or you do different classification based on what your research needs. So if maybe your research need to divide the ages based on the usage of technology, so maybe you use some ages, we have also some classifications like baby boomers or like others. So when you want to divide the classes, you need to do some small research to see whether the type of data you are trying to divide it as classes has any specific background for classification. So these things you need to keep it in your mind. If you remember also yesterday, after we calculate the frequencies, how we calculated the frequencies, actually we count, or we can use a tally. If you remember yesterday, we count one by one and we use, then we found the frequency, then we calculated the relative frequency, if you remember, which was dividing each category frequency into the total number, which is the total number was 16, then we could be able to calculate. The midpoint is the lower limit plus upper limit divided in 2. So if you wanted to calculate the midpoint of this first one, is 18.5 plus 25 divided in 2. So it will be equal to 21.75. The second one, which is 25.1, if we add 20, can you calculate the midpoint for the overweight category? It's 27.55, that's right, because it is the lower limit plus upper limit divided in 2. So this is what we call it, the midpoint. Also, as we talk, we have the class interval, which is subtracting the lower limit of the class from the lower limit of the next higher class, which is like 18.5, which is 25.1 minus 18.5, which is the class interval when we should change one class to another class, but this one normally it's easy. We have the suggested class interval when you want to do suggesting for class interval. Sorry. We put the highest value minus lowest value, we divide on number of classes. So let's see if you want to do suggestion for class interval in case we don't have this background. So here the highest number is 32.1. 32.1, we deduct from it the lowest value. The lowest value here is 22.8. In case we want to divide into 3 classes, so it's a 3. So this is what we call it the suggested class interval, which is we put the lower, we add a 3, it will be the higher, then again the 1 point after that we add 3, the higher, then we put then the higher. So if we use this suggestion for a class interval, which is 3.1 as we calculated, so our lowest point it's 22.8, we add 3.1 for it, so it will be like this. Let me try to put it here. So we have the minimum one is 22.8. We add that 3.1 for it. So this is this is the first class. Then the second class it will be 26. We add for it 3.1. It will be 29.1. Then it will be 29.2, then 29.2 plus 3.1, it will be 32.3. Like this, we covered all the items here. Okay, so in case you don't have a class interval, in case you don't have classes based on the previous studies, in case you don't have details, so you can use this equation to calculate the suggested class interval. Like we took the highest value from our data, we deduct from it the lowest value of our data, then we divide on number of classes. So here we decided to divide on to create 3 classes. So we reach to this one as our classes. But for this study, for this type of data, for the BMI, we have already specific classes is known over the world, so we use it. Okay, so this is one of the suggestions how you can calculate the classes in case you don't have a background data. You can do that using the this equation, which is we already talked about it, this equation. Okay, so this is what we were talking about it in yesterday class, so it's somehow a small recap. Okay, so now we will move to calculate the frequencies but using Excel. Okay, so again, now we're gonna to learn how to do the frequencies using Excel. This is the Excel. We are taking similar example. This is a BMI of the students, which we discussed earlier. Same example exactly, nothing changed. So we need first to calculate, when you want to calculate the frequencies, the relative frequencies, the cumulative frequencies, we need to calculate some important information, which we discussed also in the class. First, we need to calculate the total. Do you know how to calculate the total of, how to count the total of those responses, the total of those responses or the total of this data, how to count it using Excel? What is the function you are using to count the total in Excel? So let's see how we can count the total of items we have here. Count function is very easy. It's just you put count. So for count option, we just, for count option, you just put count. Let me put it for you here. Count. You see? This one is a function to calculate the total, which is count. And this between the two brackets are the cells where the items available. So the main function is the count. So I highlighted for you in yellow color. The main function is count. So you put equal, you put count. You will see this is one, the count. Double click on it. Then you select the cells containing the data. You put enter. So it calculated for you 16. So we have 16 items. So the first function to calculate the total number of data set we have, it's count. We put equal count. See, this is the function. We double click on it to activate it. Then we select the data, the range of data we have. We click enter. Then we will see it calculated for us. That is 16 items. Then we need to calculate the minimum number. We need to find the minimum number. How to find the minimum number? We just put equal min, M-I-N. Then we select the range of data. Okay. So how we calculate the midpoint is equal. We click on the maximum which we calculated. Sorry. Equal, we open a bracket. We click the maximum. We put plus. We click the minimum. We close the bracket. We divide in 2. You see how we do the equation? We click enter. So the midpoint is 27.45. Again, how we calculated the midpoint? Based on the equation we know, which is highest plus lowest divided in 2. We already calculated the highest, we already calculated the lowest. So we put equal, we open a bracket, we choose the highest, we put plus, we choose the lowest, we close the bracket, we divide in 2. Okay? Enter. This is how we calculate the midpoint. So this is how we calculated some important number. Let's continue to calculate our frequencies or for the categories. If you remember in our example, we put the lower limit and upper limit for our frequencies, right? So we have the upper limit of each one. How we can calculate the frequencies? Calculating the frequency, it has somehow specific rules we need to follow. How we calculate the frequencies distribution for these categories? We select the cells where we want to show our frequencies. Then we type in the function here, in the function place, we put equal, we put frequency, double click in the frequency. First, we select the set of data which we want. Then we put comma. We select the upper limits. Okay? Then we don't press enter. We press Control Shift Enter. It's gonna to calculate for us the frequencies of those classes. We learn how to calculate the total, minimum, maximum, and the midpoint. Let's learn how to calculate frequencies, relative frequencies, and cumulative. Actually, somehow the most complicated is the frequencies. How we calculate it? This is the set of data we have. Here are the upper limits we have. So what we put first, we need to select the cells where we want to put the frequencies. Select the cells where you want to calculate the frequencies. You go to the function tab here. You put equal, FRE. You will find the frequency. Double click. Select the data, then comma, select the upper limits. You see, we put equal, frequency, we select the set of data, then we put comma, we select the upper limits. Then we don't press enter, we put Control Shift Enter. You see how it calculates the frequencies of the data. Control, Shift, Enter. Then, you remember that relative frequencies is dividing the frequency on the total, right? So how we calculate it? Equal the frequency of the cell or frequency of the class divided on the total. Enter. It will show us. Sometimes it's gonna to show us as just number 0 point something. We need to change the cell type. So let's say if we do it as normal, this one it's showing as decimal. If you don't want it to show as decimal, it will show like this. In the normal calculation, it will show like this. How this one is calculated, the relative frequencies is equal the frequency of this cell divided on the total number of data. We put enter, it's gonna to calculate for us. If you want to calculate the others, we can also put equal the frequency divided on the total number of data. Or we can just drag and drop, but we need to fix this cell by putting dollar behind the letter and number. Then we can drag and drop. So like this, it calculates for us the relative frequencies for those classes. If we wanted to show as percentage, we select the cell, right click, we go to format cells, we choose percentage. So if you want this one number to show as percentage, we select the cells, right click, we put format cells, we select percentage. Then we put OK, it shows us as percentage. Okay, this is the relative frequencies, which is frequency divided on total number. Then cumulative frequencies. How to calculate the cumulative frequencies? The first class is equal to its frequencies. You see, I just put equal to the frequency of this class. How we calculate for second class? Second class is equal to the previous cumulative frequencies plus this class frequency. Then the third class equals to the previous cumulative frequency plus this class frequency. So the last cumulative frequency should be equal to the total number of data set. Again, how we calculate the cumulative frequencies? First class is equal to its frequency, nothing extra. For second class, it's equal to the previous frequency, previous cumulative frequency, plus this class frequency. Third class equals to the previous cumulative frequencies plus this class frequency. Is it clear?